Alright, so today we're going to talk about the if statements. Now before we start this video, I want to mention that for this specific video, we changed the environment. So we're going to use REPL 8 to write our code and actually test our code. Alright, so let's talk about the if statements. Now usually in programming, you're going to have to perform or solve certain tasks based on certain conditions, based on certain inputs. For that matter, here's where if statements actually come into use. If statements are basically structures that test a condition, and if that condition is true, perform a set of instructions. So the syntax for the if statement is actually pretty simple. You write the if keyword and then parentheses, and inside parentheses you're going to use a condition. You're going to write a condition based on which, if it's true, it's going to perform the instructions, and if it's not true, it's going to skip the instructions. And then you're going to use accolades to highlight what instructions are being part or are being associated to the if statement. In order to write a condition, you're going to need to use a couple of operators. Now these are different operators from those which I've presented to you in the operators video. So the first 6 operators are pretty logical. So the first operator is the less than operator, which is presented as the less than symbol, and as the name says, it actually just tests if a number is less than another number. Less than or equal to is represented by the less symbol followed by an equality symbol, and tests if a number is less than or equal to another number. The next operator is greater than. We have greater than or equal to, and here we have the equality operator, which is represented by 2 equality symbols. Now here is where many people get confused. In C++, a single equality symbol is actually the assignment operator. We use equality to assign a value to a variable. In order to test an equality, you use 2 equality symbols. And last but not least, the not equal to or different than operator is represented by the exclamation mark and equal sign. Alright, now let's analyze this program right here. So we actually wrote a program that takes a number and tests if it's odd or even. If it's even, it's going to print the message even followed by its value divided by 2, and if it's odd, we're going to print the message odd and then the message done. Alright, so first of all, we have declared a variable that is called n, and we have declared it of type int. Why int? Because a number is an integer. Alright, then we perform the cin instruction in order to take the input from the console, and then here's where the if condition statement actually comes into use. So based on how the number is, we're going to print a message. So first of all, we test if a number is even. So how do we do that? Well, as you might recall from our operators video, we said that a number is even if the remainder of the division of that number by 2 is actually equal to 0. The remainder of a division is actually represented by the percentage sign. So we just say n percentage 2, which basically means the remainder of the division of n, our number, by 2. If this remainder is actually equal to 0, then this whole condition will be true, and therefore all the instructions that are placed inside these 2 accolades will be performed. Why? Because these instructions belong to the if statement. So the first instruction will be to print the even message followed by an end line, and then to print the value of n by 2. Now here is where we can actually get more sophisticated with the if statements. Now normally you can write a simple if statement, and if the condition is true, it will perform the instruction. If it's not, it will just skip the instruction and continue with the normal flow of the program. So let's just ignore this else statement right over here. If the condition of this if statement was false, it would just skip all these instructions and continue on line 16. On line 16 we don't have any instructions, 17 no instructions. On line 18 we have the return 0, which actually will end the program. So let's test this program. First of all, we verify if 4 is even or odd. So for this instance it's even, and the value of 4 over 2 is actually 2. Now if we test this program for the value of 7, it will actually do nothing. Why? Because it will test if the remainder of the division of 7 by 2 is equal to 0. Obviously it's not. And then when the condition is false, the if statement is false, and therefore it will actually just skip all these instructions. and just move on to line 16. And the first instruction that comes after the if statement is actually return 0. So here's where the else statement comes into use. You can consider it as being, oh, I forgot the semicolon right here, the never-ending story with C++. Alright, the else statement is actually like a safe backup for the if statement. So how does it actually work? So the syntax is the same. You have the if statement, and then you can actually just write the keyword else and then accolades, and inside those accolades will be all the instructions that are associated to the else statement. So for this instance, if the condition of the if statement is false, it will skip all these instructions and go straight to the else statement, and in here it will perform all the instructions that are in the else statement. Alright, so let's test this for the number 7, which is an odd number. It will print the message odd and then done, because the condition was false and it jumps straight to the else statement. Now let's say that we want to perform something or print something or do anything else that is completely unrelated to the if or else statement. So even if the if statement is true or it's not, we want to print something or do something, we just simply write cout and let's say something and the semicolon. Now if this condition is true, the program will execute all the instructions that I've highlighted right here, and obviously it will skip all these instructions. If the condition is false, it will skip these set of instructions and jump right to the else statement. In both cases, the next thing that the program will do is actually the line 20, because if the condition is true and it skips the else, it will go to line 20 and will print something. Else, if the condition is false, it will skip these instructions, jump to else, and after else will jump to the next instruction. So in both cases, I forgot to print an end line. So in both cases, something is going to be printed. So let's try for the number 4. It writes even and the value of 4 by 2 and the message something. Now if we test for an odd number, the same thing happens. Alright, now you can actually chain if statements. So let's say, alright, if the number is even, I want to do this. Now if the number, let's say it's not odd, but it actually divides by 3, I want to do something else. And if both cases are false, I want to perform the else statement. Here's how you can chain the if statements. So first of all, I want to mention something. If for some reason you have just one instruction that comes after the if condition statement, you can actually omit writing the accolades. In that case, the program will actually take whatever is the first instruction that comes after the if statement. Alright, now let's remove these two accolades and actually let's comment the else statement in order to understand this example. So this program has been reduced to just verifying if a number is even. So if it's even, it's actually just going to print the message even, and obviously it's going to print the next instruction. If it's not, it's just going to skip this instruction, because only this instruction will be associated to the if statement, because we have no accolades, and the program will automatically just take the first instruction it sees that comes after the if statement. So for example, if we test this program for the number 7, if we had accolades, both of these instructions would have been skipped. But in this case, we don't have accolades. Only the first instruction will be associated to the if statement, and the next instruction will be printed or performed regardless of how the condition of the if statement is. Alright, so let's test this program. We see that it has printed the value of 7 divided by 2, obviously rounded to the nearest smaller integer, because that's what the slash symbol does, it's the division. Alright, now let's return to chaining if statements. So now chaining if statements is actually pretty simple. You write an if, the first condition, the first set of instruction, and then else and another if. It's actually pretty logical if you think about it. And so on. You can chain as many else if statements as you want. And at last but not least, you have the final else statement, which is actually being performed when all of the previous conditions are false. So for this example, let's actually write another if statement. So we're going to use else if, and let's test if the number is actually being divided exactly by 3. So that is, if the remainder of the division of n over 3 is equal to 0, then I don't know, let's just print n for this instance. Alright, in this case, let's give an example of a number that is odd, so the first condition will be ignored, but is actually being divided exactly over 3. Let's give the example 9. 9 is being odd, but it actually divides exactly by 3. Now if we run this program, in this instance n is 9, it's odd, so it's going to skip the if statement, it will go to the else if, the condition is true, so it will perform this instruction, and then it skips the else statement and goes right next to the first instruction that comes after the else statement, that is something. So it first prints n, and then the message something. Now I think you've got the hang of how the else if statements work. The last thing that we want to discuss on this video are the operators OR, AND, and XOR. So sometimes you have if statements that require multiple conditions that happen at once or separately. In this instance, if we want to test if two conditions are right at the same time, we can use the AND condition, because you simply just say if condition 1 is true and condition 2 is true, then perform the test. If you want to verify if at least one condition is true, you can say if the first condition or the second condition, either one, they can be both, are true, perform the if statement. And we're going to talk about XOR later. So let's write a program that essentially takes a number and verifies if that number is greater or equal than 5 and smaller or equal than 9. So we declare a variable, let's name it x, which is of type int because it's a number. Then we take that value from the screen, from the console in this case, and then what do? We say if, and here inside parentheses we write our condition. So the first condition is if x is greater or equal than 5. And then we want to use the AND operator, which was represented by a double ampersand symbol. So if x is greater or equal than 5 and represented by the double ampersand symbol, x is less than or equal to 9. And for this instance, let's just give another condition which will say if x is also different than 6. Alright? If this condition is true, let's print just the message true. Alright? 5 is greater or equal than 5, it's smaller or equal than 9, and it's different from 6. So in this case, it will print the message true. Now, if we give a number that is smaller than 5, it won't do anything. We still didn't use any else statement. So the next instruction will be return 0, which actually just ends the program. Now, if we write the number 6, the same thing happens. Why is that? Well, let's see. 6 is greater or equal than 5, which is true, and 6 is smaller or equal than 9, which is true, but the last condition is false. Now, the AND operator works as follows. If all the conditions are true at the same time, then the overall condition, the overall if statement is true, else it's not. Now, if we want to verify if at least one of these three conditions is true, we can use the OR operator. The OR operator is represented by the symbol of two parallel lines. So let's say, for this same example, if we write 6 is greater or equal than 5, so the first condition is true, the second condition is true as well, the third condition is false, but it doesn't matter. We already have at least one condition which is true. So if we test this program, it's going to print true. Again, let's test for the number -1. So -1 isn't greater or equal than 5, so this condition will be false. Instead, it's less than or equal to 9, and it's different from 6. So if we try this number, it will print the message true. And for the last operator, XOR actually stands for exclusive OR. This is actually a pretty logical operator. Now if we look at the OR operator, it actually requires at least one condition to be true. If we look at the AND operator, it requires all the conditions to be true. If at least one condition is false, then the overall result will be false. Now XOR, or the exclusive OR, actually requires at least one and maximum one condition to be true. So for this instance, I'm just going to change the last condition as being different than 11. So if we try the number -1, the first condition will be false, the second condition will be true, and the third condition will be true as well. We have two conditions that are true, the overall result will be false because XOR requires one condition to be true. So if we type enter, nothing happens because The if statement was false. It skipped the instruction. Now, in order to better understand how the XOR works, I'm just going to remove the second condition. So now we have only two conditions. In this case, let's give the example of 7. Alright? In this case, 7 is greater than 5, so the first condition will be true, but 7 is also different from 11, so the second condition will be true as well. We have two true conditions, and therefore the overall condition, the overall if statement will be false, because XOR requires just exactly one condition to be true. So we test this program, we see that nothing happened. Now let's say we try for the test case of 11. The first condition will be true because 11 is greater than 5, and the second condition will be false because 11 isn't different from 11. So the overall condition will be true, and this program will actually print the message true. Alright, that is all for today. I hope you liked this video, and I'll see you next time.